Are you ready to uncover the secrets lurking at the edge of our solar system? Imagine a tiny intrepid explorer, Voyager 2, launched from Earth in 1977, a time when humanity was just beginning to dream of reaching beyond our planetary neighborhood. This spacecraft, no larger than a small car, was built with the hope of exploring the unknown, carrying with it the ambitions and curiosity of an entire species. Voyager 2 was never meant to travel so far or for so long. Its journey was expected to last only a few years, but it has far surpassed every expectation, venturing into realms no human-made object had ever reached before. Its original mission was a grand tour of the gas giants, Jupiter, Saturn, Uranus, and Neptune, capturing breathtaking images and invaluable data that would forever change our understanding of these distant worlds. But its true legacy lay beyond, as humanity's first emissary to the stars, venturing into the vast interstellar medium where no spacecraft had gone before, carrying our story into the unknown. Bolted to each Voyager is a golden record, a time capsule of Earth, inscribed with greetings in 55 languages, music from across cultures and centuries, and images of life on our planet, our landscapes, our people, our hopes and dreams. It is, quite literally, a message in a bottle cast into the cosmic ocean, drifting endlessly through the darkness, waiting for a finder. Should another civilization find it, they'll know humanity once reached for the stars, that we long to connect, to share who we are, and to be remembered. For nearly half a century, these probes have survived the harsh realities of space, cosmic radiation, freezing temperatures, and the endless silence, persisting where nothing else from Earth has endured. Against all odds, they continue sending back precious data from the edge of our solar system, expanding our knowledge with every faint signal received. Their power is fading, and every bit of data is a final whisper from the darkness, a last message from a distant outpost before the silence returns. Voyager 2 continues its lonely voyage, an extension of our senses in a realm we cannot visit, a silent ambassador carrying our presence into the infinite. It has transformed our understanding of the solar system, revealing unexpected beauty and complexity, showing us storms on Jupiter, rings of Saturn, and the icy mysteries of Neptune. The story of Voyager is our story, a tale of reaching out from our cradle to touch the cosmos, a testament to our curiosity, our ingenuity, and our enduring hope that we are not alone. To truly appreciate Voyager 2's most groundbreaking discovery, we first need to unravel the mystery of the heliosphere, a colossal invisible bubble sculpted by the sun's relentless solar wind. This vast region is not just a boundary, it's a dynamic frontier that separates our solar system from the rest of the galaxy. The sun is far from a quiet star. It constantly hurls streams of charged particles, known as the solar wind, outward in all directions. These particles race through space at incredible speeds, creating a protective shield that envelops every planet, moon, and asteroid in our solar system. This shield, called the heliosphere, acts as our cosmic guardian. It deflects and weakens dangerous cosmic rays from deep space, making life on Earth not only possible but sustainable. Without it, our planet would be bombarded by radiation, threatening all forms of life. Interestingly, the heliosphere isn't a perfect sphere. Instead, it's shaped more like a windsock, flattened at the front and trailing behind, molded by the sun's movement through the galaxy and the pressure of interstellar space. Its boundaries are constantly shifting, responding to solar activity and galactic forces. The sheer scale of the heliosphere is staggering, so immense that even light, the fastest thing in the universe, takes more than a full day to travel from one side to the other. It's a bubble that dwarfs our entire solar system. For decades, scientists could only imagine where this bubble ended. Its outer boundary, known as the heliopause, was a subject of intense debate and speculation, with only indirect evidence to guide their theories. That's why Voyager's extended mission was so crucial. It was designed to journey farther than any spacecraft before, to provide the first direct measurements of this mysterious, uncharted region at the edge of our solar system. But what would a spacecraft actually experience as it crossed from the sun's domain into true interstellar space? Would the transition be sudden or gradual? No one knew for sure. When the answers finally arrived, they were more astonishing than anyone had dared to predict. The data upended long-held assumptions and revealed a boundary far more complex and dynamic than expected. Voyager was about to peel back the curtain on a phenomenon that would challenge everything we thought we knew about our place in the cosmos, opening a new chapter in humanity's exploration of the universe. Every bubble has an edge. The heliopause is ours, where the sun's influence ends and interstellar space begins. Crossing the heliopause was Voyager's ultimate goal. Voyager 1 crossed first in 2012, Voyager 2 followed in 2018, providing even richer data. Scientists expected a smooth transition. Solar particles would drop, cosmic rays would rise, but space is rarely so tidy. As Voyager 2 approached, its instruments registered dramatic changes. Solar wind density plummeted, cosmic rays surged. The probe had crossed the boundary. But then, its sensors detected something utterly unforeseen, a dramatic spike in temperature. The probe had flown into a blistering invisible barrier. The universe had a major surprise waiting at the edge of our solar system. As Voyager 2 passed through the heliopause, the invisible boundary where the sun's influence fades and interstellar space begins, it encountered a phenomenon no one predicted, a cosmic surprise that would challenge everything we thought we knew about the edge of our solar system. Suddenly, the plasma temperature around the spacecraft skyrocketed to nearly 50,000 Kelvin, hotter than the very surface of the sun itself. This was not just a minor fluctuation but a dramatic spike, a searing wall of heat that seemed impossible so far from any star. How did the probe survive such an inferno? The answer lies in the nature of the plasma itself. Despite its incredible temperature, the plasma was so thin, so diffuse, that it couldn't actually transfer much heat to Voyager 2. It was a paradox. Unimaginably hot, yet almost harmless. Imagine being touched by a few sparks rather than being engulfed in a raging flame. The difference is all about density, not just temperature. Voyager 2 was surrounded by heat but not burned by it. This so-called wall of fire is actually a turbulent, chaotic zone where the solar wind, charged particles streaming from our sun, collides head-on with the interstellar medium, the thin gas and dust between the stars. Here, the energy of motion is violently converted into heat. It's like a cosmic traffic jam, with particles piling up and creating a region of immense, almost unimaginable energy. The boundary is not smooth or gentle, but a place of constant turmoil and transformation. This discovery forced scientists to completely rethink the heliopause. It's not a simple, static line drawn in space, but a dynamic, fiery frontier, constantly shifting, shaped by the forces of both our sun and the galaxy beyond. The revelation stunned the scientific community, highlighting just how little we truly understood about the outermost reaches of our solar system. Each new discovery at the edge brings more questions than answers. The heliopause is not a calm, gentle shore as once imagined, but a raging, ever-changing sea of fire, a place where the familiar meets the unknown in a spectacular cosmic clash. Voyager 2's crossing was not just a milestone in human exploration, it was a warning, a reminder that the universe is full of surprises, and that the boundaries we draw are often more mysterious than we realize. The edge of our solar system is far more extreme, more dramatic, and more alive than we ever imagined, a true frontier at the edge of forever. The discovery of the Wall of Fire sent shockwaves through NASA and the scientific community. Our models of the solar system's boundary were profoundly wrong, raising urgent questions for future missions. If such extreme conditions exist where we expected none, what else might we be missing? The heliosphere is our shield against cosmic rays. Now we must ask how well it really works. Is the boundary stable, or does it fluctuate, letting in bursts of radiation? Understanding the heliopause is now crucial for protecting astronauts and technology. The Wall of Fire shattered old paradigms, demanding new models and deeper understanding. It's a humbling reminder. Space is full of unknowns, and our quest for knowledge is far from over. As if the Wall of Fire weren't enough, Voyager 2 revealed another cosmic mystery: magnetism. Scientists expected the sun's magnetic field and the interstellar field to meet at an angle, but both Voyager 1 and 2 found the fields nearly perfectly aligned, billions of miles apart. This was no coincidence, but a large-scale feature of our cosmic neighborhood. How could the sun's field be so neatly aligned with the galaxy's? This discovery complicates our understanding of how the heliosphere interacts with interstellar space. It hints at a deeper connection between our solar system and the galaxy. The alignment is a cosmic clue, pointing to physical processes we have yet to understand. Before reaching interstellar space, Voyager had already revolutionized our view of the solar system. Its grand tour revealed erupting volcanoes on Io, showing that geological activity wasn't unique to Earth. Voyager discovered Jupiter's faint rings, Uranus's dark rings, and Neptune's ethereal rings. It clocked Neptune's winds at over 1,500 miles per hour and found cryovolcanoes on Triton. Voyager hinted at hidden oceans beneath Europa and Enceladus, now prime targets in the search for life. These discoveries reshaped our understanding of where to look for activity and habitability. Voyager showed that tidal forces, not just sunlight, could power active worlds. The concept of a habitable zone expanded beyond the warmth of a star. Each flyby replaced simple sketches with detailed portraits of vibrant, active systems. The Grand Tour rewrote the rules of planetary science. In 1990, Voyager 1 turned its camera back toward Earth, capturing the iconic pale blue dot image. From nearly 4 billion miles away, Earth appeared as a single pixel, a mote of dust in a sunbeam. Carl Sagan called it a powerful lesson in perspective, showing the fragility and loneliness of our world. All our history, triumphs, and conflicts play out on that tiny stage. The image challenges our self-importance and urges us to cherish our only home. There is, as yet, nowhere else for us to go. The pale blue dot was Voyager's parting gift, a family portrait of the solar system. Afterward, its cameras were switched off forever, its gaze fixed forward toward the stars. From then on, Voyager's journey was not just about looking back, but about venturing into the unknown. Nearly 50 years on, Voyager 2 has permanently altered our perception of the cosmos. Its discoveries, the wall of fire, the magnetic alignment, are paradigm shifting. The more we learn, the more we realize how much we don't know. What heats the plasma at the heliopause? Why are the magnetic fields aligned? Is the wall of fire stable? These questions will drive the next generation of explorers. As Voyager's power fades, its journey continues, drifting silently through the Milky Way for millions of years. The probes are humanity's first true starships, carrying our message to the stars. Voyager's legacy is a lesson in the value of exploration and the power of curiosity. It has changed our place in the universe, showing us both the vastness of space and the preciousness of our world. The voyage continues, and the cosmos still awaits.